We are travelers inside a giant, invisible fortress. Our solar system is encapsulated by the Heliosphere, a massive protective bubble inflated by the relentless blowing of the sun's wind. This boundary is our cosmic shield. It offers vital protection from the harsher radiation roaming the rest of the galaxy, creating and maintaining a habitable solar system where life can exist. But how does this invisible frontier interact with the local galactic neighborhood beyond? To answer this, humanity had to build a new kind of explorer. On September 24th, 2025, at 7:30 a.m. Eastern Daylight Saving Time, a Falcon 9 rocket roared to life at NASA's Kennedy Space Center, Launch Complex 39A. On board was a 900-kilogram orbiter designed to push boundaries, the Interstellar Mapping and Acceleration Probe, or IMAP. Packed within its sturdy frame were 10 highly sensitive scientific instruments, each a masterpiece of engineering. Its departure marked the beginning of a crucial quest to decode the invisible structure of our cosmic home. Managed by NASA and the Goddard Space Flight Center, this modern-day celestial cartographer bypassed Earth's immediate orbit, journeying 1 million miles away toward the Sun to a unique gravitational anchor point known as the Sun-Earth L1 Lagrange Point. IMAP visualizes the invisible using an orchestrated arsenal of 10 instruments, allowing scientists to study fundamental physics across scales both tiny and immense. It begins at the mid-range, with SWE analyzing the swarm of electrons. Simultaneously, SWAPI, CODICE, and HIT measure the diverse spectrum and diverse energies of solar ions. To map the distant boundary, IMAP Low, IMAP High, and IMAP Ultra serve as the main cameras, catching the crucial energetic neutral atoms arriving from the edge of the solar system. Alongside IDX, they also hunt ancient interstellar particles that drift through our neighborhood. All while GLOWS and MAG monitor vital UV light and magnetic fields. Together, they uncover the basic cosmic building materials of our universe. But IMAP is more than a cartographer. It is a vital shield for our modern civilization. The sun is a restless engine, constantly flooding space with dangerous particles and radiation. This space weather can produce hazardous conditions, harming voyaging astronauts, damaging spacecraft, and disrupting global communications and electrical grids on Earth. Sitting a million miles away at the L1 point, IMAP supports real-time observations of the solar wind. Standing as our outer sentinel, it provides about a half-hour's warning of harmful incoming radiation, safeguarding both humanity's technological heart and its explorers in the deep. The journey has successfully reached its destination. Having captured its historic first light and looked back at our lonely blue planet, NASA's IMAP has officially begun its primary science mission. By tracing the tiny particles that define our vast, invisible frontiers, this mission will improve our forecasting of solar wind disturbances and draw a definitive picture of our nearby galactic neighborhood. As this robotic pioneer maps the final boundary of the sun's domain, it expands our knowledge of the cosmic processes that allow life to thrive. Reminding us that to understand our home, we must chart the edge of the unknown.